Hello students, welcome to Easy Chemistry. Today we are going to discuss a second colligative property which is called as elevation in boiling point. Okay, so when non-volatile solute is added to volatile solvent, the vapor pressure, we know that the vapor pressure of solution decreases. We have understood the Raoult's law for that. Vapor pressure of solution decreases and boiling point of solvent increases, because we know that vapor pressure is inversely proportional to the boiling point. Now we need to understand what is boiling point. A simple definition of boiling point is the temperature at which liquid starts converting into the vapor. This is one of the definitions of boiling point. Another definition of boiling point is the temperature at which vapor pressure of any type of liquid is equal to the atmospheric temperature. A temperature at which vapor pressure of liquid is equal to the atmospheric pressure, that temperature is considered as a boiling point of that liquid. Okay, so what happened when we take a pure water, and another side if we take this a water with the non-volatile solute, it means if I take here pure water, here I will take the salt solution. Okay. So what happened? This salt molecules present in a water resist this solvent molecule to convert into the vapor state. So it requires more temperature and more heat energy to convert into the vapor state, or to convert its vapor pressure into the atmospheric pressure. So if the pure water boil at 100 degrees Celsius, the salt solutions boils at 104 degrees Celsius. The 4 degrees Celsius, that the temperature had been increased by the 4 degrees Celsius. So we can say that 4 degrees Celsius is the elevation in boiling point. Okay? If I represent graphically, if I represent this thing in a graphically, so I can represent it like this, that vapor pressure of solution, or either you can say vapor pressure versus boiling point. I draw the graph, vapor pressure versus boiling point. So if this plot is for T0B, T0B it means for pure solvent, pure water. If I add any type of non-volatile solute into this solvent or into this water, what will happen? Its boiling point will increase. It means here it will be a TB. This is for solution containing non-volatile solute. Okay, now difference between TB and T0B is increase in the boiling point. TB is a boiling point with the increased by adding non-volatile solute. So this is TB, boiling point of pure of solution. T0B is a boiling point of pure solvent. The difference between TB and T0B is called as delta TB. Correct? Hope all of you understood this much. So I can write like this. I will write delta TB, that is elevation in boiling point, is equal to TB minus T0B. Okay? Here delta TB is elevation in boiling point, TB is a boiling point of solution, T0B is a boiling point of solvent. Then, now, understand that elevation in boiling point is directly proportional to molality of solution. Yes? So, I can write like this. Delta TB is directly proportional to the M. Right? If I remove this proportionality sign, the formula will be a delta TB is equal to KB into M. So what is KB here? What is KB here? KB is called as molal elevation constant, which is also called as ebullioscopic constant. Also called as ebullioscopic constant. How will you define this molar elevation constant? So you can write like this. Delta TB is equal to KB into M. So we can write like this. KB is equal to delta TB upon M. If M is equal to 1, it means 1 molal solution. So what will happen? KB is equal to delta TB. Right? So I can write like this. The elevation in boiling point for 1 molal solution. The elevation in boiling point for 1 molal solution is called as molar elevation constant or a ebullioscopic constant. Okay? Now what is the unit of delta TB? KB, molar elevation constant. So we can write like this. First we can write like this. For delta TB it is Kelvin. For molality it is mole per kg. Anna? So in the final we can write like this. Kelvin kg per mole. Okay? This is your unit for KB. So hope all of you understood this much. What we have done, when and any type of non-volatile solute, जब कोई भी non-volatile solute को हम लोग volatile solvent में डालेंगे, तो what will happen? उसका वेपर प्रेशर डिक्रीज हो जाएगा, बॉइलिंग पॉइंट इंक्रीज हो जाएगा. सही बात है कि नहीं? यहाँ पर हम लोगों ने कंपेयर किया, वी कंपेयर्ड प्योर वाटर एंड सॉल्ट सॉल्यूशन. So when we compare pure water with the salt solution, what happens? The pure water boils at 100 degrees Celsius and salt water, a salt solution boils at 104 degrees Celsius. Due to this salt molecule resist this water molecule to convert into the vapor state. Okay? Which increases the boiling point. And we have written in a graphical way, and one is in a mathematical way to represent the elevation in boiling point. Remember, this KB is called as molar elevation constant. Okay? Okay. Yes, students. So, in a previous class, हम लोग यहाँ तक इस फॉर्मूला में पहुंच गए थे for elevation in boiling point. Delta TB is equal to KB into M. Delta TB is elevation in boiling point. KB is molar elevation constant. M is molality of solution. what is molality here? So we can say that molality is number of moles of solute upon mass of solvent in kg. Previously I said 2 is for the solute, 1 is for the solvent. So N2 upon mass of solvent in kg. Okay, if I write like N2 as a W2 upon M2, mass upon molar mass, W1 in kilogram. Instead of kilogram, if I write gram, so it will be W2 upon M2. If W1 is given in a gram, तो ग्राम को किलोग्राम में डिवाइड करने के लिए व्हाट विल डू, डिवाइड बाय 1000, तो 1000 विल गो अप, इट विल बी लाइक दिस. ठीक है, तो ये पूरा मोलालिटी की जगह पर ये वाला फॉर्मूला रख दो. तो ये फॉर्मूला विल बी डेल्टा टीबी इज केबी into W2 into 1000 upon M2 into W1. ठीक है, this is your formula for elevation in boiling point. Now from this formula you can calculate mass of solute, you can calculate molar mass of solute, you can calculate mass of solute, molar mass of solute and elevation in boiling point. Yes? Okay? You understood this formula also. For molar elevation constant, for molar elevation constant, there is one formula for molar elevation constant, that is Kb is equal to R T0 square 1000 into IV. Of R we know that it is universal gaseous constant. T0 is boiling point of pure water. IV is latent heat of vaporization. What is latent heat of vaporization? You understood latent heat of, you heard this word in latent heat of vaporization in class 9. Latent heat of vaporization, it means it is amount of heat energy required for converting 1 kilogram of liquid into vapor at normal atmospheric pressure. So the energy which required to convert 1 kilogram of a liquid into vapor is called as latent heat of vaporization. Instead of latent heat of vaporization, you can write IV is equal to delta enthalpy of vaporization upon molecular mass of solvent M1. So your formula will be like this: Kb is equal to R T0 square upon 1000 into enthalpy of vaporization into M1. ठीक है? You can place this here and calculate if it is enthalpy of vaporization is given. So hope all of you understood this much. We understood that elevation in boiling point. Thank you.